Hello everyone. In this video, we're going to look at slack in surplus and how we would go about calculating slack in surplus. So first off, slack in surplus only exist with your non-binding constraints. Binding constraints do not have any slack or any surplus. However, non-binding constraints will have slack or surplus depending on what type of constraint it is. When we are speaking about slack, so again, slack will only exist on a non-binding constraint, but it has to be a less than or equal to constraint. So for example, if I can use less than or equal to 80 units of something, slack would mean I haven't used all 80 that I could, I've used something less than 80. And the amount of slack is the amount of units less than 80 that I would have actually used. Whereas surplus is the exact same thing, however, it is for a greater than or equal to constraint. So again, this can only exist on a non-binding constraint, and for a greater than or equal to constraint, it means that I've used more than that minimum requirement. So here, if I had to use greater than or equal to 80 units of something, and I used 100 units, well, I've used more than 80, I've used 100, I would have used 20 units of surplus. So again, slack and surplus can only exist on non-binding constraints. Slack only exists on a less than or equal to constraint, and surplus can only exist on a greater than or equal to constraint. So if we look at example 2, and we went about and we solved the optimal solution for this example, we found that we should be using 15 pounds of fertilizer A and 2 pounds of fertilizer B. We found that the optimal solution occurred at the intersection point between constraint 2 and constraint 3. So again, in determining what is a binding constraint and what is a non-binding constraint, binding constraints are constraints that exist at the intersection point of the optimal solution. And non-binding constraints exist away from the intersection point of the optimal solution. So in this case, constraint 1 was not at the intersection point of my optimal solution. It would be considered a non-binding constraint. Constraint 2 was involved at the intersection point of the optimal solution, so it is a binding constraint. Similarly, constraint 3 was involved at the intersection point of the optimal solution. So it too is a binding constraint. Now notice something that is going to happen here mathematically. When I sub in the optimal solution values into any of those constraints, so if I was to sub in my optimal solution of 15.2 into constraint 1, 5a plus 3b, I would get that that is equal to 81. If I were to do the same thing for constraint 2, 2a plus 3b, so 2 times 15 plus 3 times 2 would give me 36. And if I were to do it for constraint 3, 2 times 15 plus 5 times 2, I would end up with 40. Now notice, mathematically, I start to see why these are being referred to as binding constraints and non-binding constraints. At my binding constraints, 2 and 3, what I should notice is as I sub the optimal solution into the left-hand side of this inequality, I end up with the exact number of units as my bare minimum. I had to use at least 36. I could have used 36 or anything more, but I notice at my optimal solution, I'm using that exact bare minimum. The same thing at constraint 3, I'm using that exact bare minimum of 40. These are why the constraints are binding. If I were to alter this in some way, my optimal solution would be changed. I cannot alter these binding constraints as they would have an impact on my optimal solution of 15.2. So now I have another way of identifying binding constraints. I know I can identify them by finding the optimal solution point on my graph. Constraint 2 and constraint 3 were at that optimal solution point. I knew they were binding constraints. I can identify them also mathematically. If I sub in the optimal solution into the left-hand side of my inequality of the constraint, I should find that I end up with the exact same value as my right-hand side value. So constraint 2 that was binding, my left-hand side at the optimal solution equals exactly 36, the exact same as my right-hand side. Constraint 3, subbing in the optimal solution, I end up with a left-hand side value of 40, the exact same thing as my right-hand side value of 40. We notice that that is not what happens at our non-binding constraints. And this here helps me determine how much slack or how much surplus we have. So again, remember, at non-binding less than or equal to constraints, we will always have slack. At non-binding greater than or equal to constraints, we will always have surplus. So if I look at my non-binding constraint, constraint 1, at the optimal solution, I've used 81 units of constraint 1. Constraint 1 dealt with phosphate. I used 81 units. I had to use a minimum of 45 units, which means in terms of surplus, we've used more than we needed to. We have used 36 additional units, or 36 units of surplus phosphate. Thank you very much, everyone. Please email me with any of your questions or concerns as soon as you have them.